So this highlights the importance of doing your assessment, taking all the vulnerabilities from the application and the infrastructure, and threat modeling it, seeing, hey, I've got all these different holes in my system. Which holes can be combined for an attacker to come through and gain access to my digital assets? And you really need to consider the holes at all the different layers. You can't just do your assessment on the application in silo and then do it on the cloud in silo and not do any threat modeling across them or at all. If you're not doing that, you're losing the opportunity to identify these really basic attacks, like the one in the case of Capital One, that could happen to you. So yeah, there it is.
Hey folks. Hey everyone, Nick here from Scrut Automation, back for another episode on our podcast here. We have Farshad Abasi, founder and CEO of Forward Security, based out of British Columbia. And we're gonna have a fun conversation on this episode. We'll call it Cyber Roulette, playing with digital risk. Everyone loves playing roulette, so everyone seems to extend that into cyber as well.
Being managing risk, of course.
And we can, I think today, instead of going into, we're going to skip straight to the fun part and get into, I think, what is a huge area of risk that gets played around with, if you will. I think is software security. And Farshad here is a software security specialist and has been in the industry for a number of years, and would love to have you help us and our listeners, Farshad, learn a bit more about software security.
Sounds good. Yeah, sounds great. I'm excited to have this conversation. I think software has been an overlooked area in cybersecurity, and for good reason, because for a long time you didn't really have to worry about software security. Most companies' software resided inside their corporate environment, protected by firewalls and a walled garden. And companies didn't often expose their applications outside those boundaries. But with the advent of modern APIs and the world changing the way it is, particularly with things that are happening in Europe, governments requiring banks and whatnot to expose their functions through APIs externally. Of course, with COVID taking place since 2020, and many companies going through a digital transformation to provide their services digitally, we're seeing a lot more adoption in terms of software that's exposed outside the boundaries of traditional corporate environments, and that presents a massive opportunity to attackers because now they can, without having to go through the firewall, they can try to attack that organization's digital asset through the software that's exposed in that manner.
Yeah, no, I mean, firewalls and infrastructure were anyone ever cared about for a long time. I think it's just kind of like my thing with folks when we're talking about, where to prioritize, depending on what kind of company it is, the amount of infrastructure they have, maybe not as much as the amount of software they have, right? So many companies today, I mean, I know for Scrut, it's like we have way more software than we have infrastructure. There's just software everywhere, that's kind of our primary bread and butter as a SaaS business. Also, even, at previous companies, the infrastructure had been around long enough that in some ways it just was more work to go straight after the infrastructure. If we have Cloudflare on the WAF, for our front end, people are going to have to do a lot more there. Why not just go after something people may not be paying as much attention to? Exactly. I mean, what are some of the, what are maybe like the top two kind of things people miss when it comes to software security? Because I'm sure it's a big space.
The biggest challenge is that because security traditionally was really network focused and infrastructure focused, folks conducting assessments on software come from that background. So they don't really have a software background, or nor do they understand software. And of course, the methodologies and techniques that we apply to testing software are also not correct. The big problem is pen testing. Pen testing works wonderfully, and it's worked for a long time to be able to test infrastructure and networks. And as I mentioned earlier, that was the focus of cybersecurity for a very long time. So pen testing grew as an industry where, given X, you pen test it before you make it available to the public. The reason it works well for infrastructure and for things that are not your custom software is because, oftentimes vulnerabilities are published for software or infrastructure that has been released. So, for example, Microsoft Windows, or for Firefox, or for many other systems, or even for your Cisco switches and things like that. People find vulnerabilities, they publish them in the CVE database, and then the pen tester goes and tries to see if any of those vulnerabilities are present and whether they can be exploited. When you're building your own software, the challenge is that it's brand new software. The vulnerabilities are not published yet. The code is not out there yet. So therefore, there are no CVEs to go and find and see if you could exploit them. So the traditional pen testing goes out the window, but not completely, because modern software is composed of some third-party libraries and some custom code. So for those third-party libraries and components and packages that you're using from other vendors, yes, surely there may be CVEs, and you could use the traditional pen testing methodologies to find them and exploit them. But that only is a percentage of your application. A good chunk of your application is brand new code that you wrote. As I mentioned, there are no CVEs for it. So if you're applying traditional pen testing, you're really giving yourself a false sense of security, right? Because you're saying, hey, SOC 2 or whatever standard says I should go get a pen test. I got it done. Sure, you got it done, but did you get it by someone that understood software testing properly? Did they actually do a source code review? Did they do a design review and threat model that application? I'd say following the 80-20 rule, 80% of the time, the answer is going to be no. You probably went to a vendor that just does regular pen testing. They'll do web application pen testing, but they don't understand software, nor are those resources people that were trained on software development or understanding software. They're most likely just trained on how to do pen testing, and they're blindly testing your application. We had someone who identified a SQL injection in a client's application, but they didn't understand SQL or development, and they actually couldn't tell because the tool determined that it was a SQL injection. They just told client that that's a problem. The client came back and said, you know what? Actually, if you read the code, it shows that this will not result in a SQL injection, but because that person didn't understand coding or anything like that, they were giving a false information to the client. So these are some of the in my opinion, that's the biggest challenge, is because industry comes from the old days. Pen testing was the way, and it still is for a lot of things, the way to test things, but it isn't the way you test software properly. And OWASP actually backs this up in their testing guide. OWASP clearly states that there are several different methods to test your application. One of them is pen testing. The other one is manual inspection or design reviews, followed by threat modeling and code review. You got to do all four of those. And most people are only doing one. So therefore, they're only probably looking at about a third of their issues, and they're blindsided to all of the other issues that resist in their application because they haven't tested it properly. The good news for companies like ours is that the U.S., they put out an executive order, as you know, in May of 2021. In that executive order, they required NIST to come up with guidelines on how to test software properly. Those guidelines came out last year, and they actually align with OWASP. So they say to test software, you have to do all four things that I mentioned earlier. So this is good news to people like myself that have been having problems with the way that companies test software. But hopefully, with the U.S. executive order, this is going to push all vendors to move in the right direction and test software appropriately.
And just to recap, the four things were manual reviews,
manual reviews,
source code testing,
source code assessment analysis, threat modeling, and pen testing.
Threat modeling and pen testing. Okay, yeah. No, I mean, there's so many layers and levels to do that. I mean, when it comes to those four, is there any guidance on, of the four, if people had to prioritize? Because I'm sure not everyone has the expertise to go do all that, right? I mean, sometimes you might have people who understand. You have developers who understand the code and the source code and can do code reviews. You might have security engineers who can do threat modeling. Sometimes the two shall never meet. Hopefully they do. Hopefully they work really well together. Yeah.
Yeah, out of those, you basically said it really well. I mean, design reviews and threat modeling often require skill sets that may not be available to that dev team. We are working on tooling that makes that easier, that democratizes those things. But without the tooling and the tools that exist today, like Microsoft's threat modeling, they don't really do a good job. As a developer, as a previous developer in another life, I've tried those tools and they're time consuming, don't produce great results, and they're very confusing for developers. So we're working on building tools that democratize that process. But if I were to order them, and looking at the last 15 years that I've been doing application security full time, I've been and I've, I've been doing both, right? Like testing, designing, reviewing the design from a security perspective, threat modeling, code review, and pen testing. I'd say the average application has about 20, 25 threat scenarios. These aren't vulnerabilities. Threat scenarios are a combination of vulnerabilities, is finding which vulnerabilities that can be combined together to form an attack pathway. So let's say an average application has hundreds of vulnerabilities, but from my experience, when you combine them, you come up with around 20 threat scenarios. And they carry high, medium, and low risks. Out of those, about half of them often is discovered through design reviews. So this demonstrates the value of design review, is that on an average application, you have 20 threat scenarios, 10 is coming from pen testing, 10 is coming from your design review. So that highlights the importance of design review. And again, in my experience, those 10 items that we find through design reviews, they're often your high and medium risks. Whereas the ones we find from pen testing, the other 10 or so, they're often medium and low risks. So super interesting that the high risk issues are often found by doing the design review, not by doing the pen testing. And then, but as you said, design reviews do require some skill. So there are ways to train developers so that they can do this themselves. One of the things that we do with some of our clients is that we mentor their developers. So we attend a few of their sessions with them where they bring in user stories or things that they're working on, and we show them how to look at that. And I did this when I worked at HSBC. We had hundreds of development teams around the world, and there was no way that we could support them directly one-on-one. So we created a threat modeling training, and then I went around to all the different teams and we trained everybody in terms of how to doing them. So with a bit of mentorship and training, it can be simplified to the level that developers can do the basics. But we have to admit that both security and software are fairly large domains. So we can't expect the developer to become a security professional and do that at the level that a security professional would do. But if they're trained and mentored at a level where they can deal with the low-hanging fruit, following the 80-20 rule, 80% of our problems are low-hanging fruit and they'll go away. And then the 20%, well, that's saved for your annual assessment that you hopefully go to a subject matter expert like us, and then we can deal with the 20% or identify the problems that were not low-hanging fruit and the developers couldn't figure out on their own.
I mean, there just are never enough people. I totally have been there where it's just like a long inbox of like design review requests.
Yep.
And the different development teams just chomping at the bit to get their design reviews done. It's just like never enough time. Design review team's never going to be big enough. Have had people, come to my desk during work and just be like, hey, can you do this right now? Is it done yet?
Yeah, it's better, and it's better to make security not be a blocker, right? Because I have both worked at those large enterprises. Same thing with me. Like my team, we had a security team that would do design reviews for all the application teams. But as you said, there's just not enough security people, right? So enter DevSecOps. It's interesting because DevSecOps is really misunderstood. If you go and read the official pages where they talk about it, DevSecOps is supposed to be a cultural transformation. It's supposed to address that shortage of security folks problem. Is that if you embed people, process, and technology with particularly focusing on enablement, you can enable that team to do that, go from a DevOps team to become a DevSecOps team. The mistake that a lot of folks make is that they think DevSecOps is a position. They think it's a security person, that I can go hire this DevSecOps person and it's going to solve my problems. But as you and I just said, there's just not enough security people. And so we just have to admit that we can't go and hire a security person for every DevOps team and make them DevSecOps. That's just not going to happen. So really the idea of DevSecOps is, how do you embed process? How do you embed best practices? How do you enable that team so then you can federate security? And that's where ideas like security champions models come in, right? So imagine you work at Expedia where you used to be, And then what you would do is you would go to all of those different software development teams, and then each team would appoint someone as the security champion. It doesn't have to be a security expert. It can just be someone in that team that has interest in security. And then what the company would do is they would support them in that journey, say, hey, John, you're in this DevOps team. You're still doing your regular work. You might be a developer. You might be working on the ops side of things. You might be doing QA, but you're still in that DevOps team. We're going to allocate 20% of your time so that you can deal with security. You can learn about security. If there was an annual training budget, we give you a little bit of extra budget to maybe go learn something about security. So now you're taking that developer, you're enabling them so they're becoming your on the ground person. So that instead of going and hiring a security person that doesn't exist, or they're really in short supply, you now have someone that's representing security. They may not know everything, but you federate security and you support them. So at Expedia, for example, what you could have done is that you say, okay, every team now has an appointed security champion, but I only have 5 people in AppSec. Those AppSec people are going to federate and support the champions. That way, you're able to scale really large. So this is what large enterprises do. And this is what we did, by the way, at HSBC. We had about 20 AppSec people in the core team. We were supporting hundreds of development teams through the security champion model. Now, the challenge is, what if you're a small startup, right? You're not going to have an AppSec team. So great, Farshad, I only have 2 teams. Let's say I appointed security champions in both of those teams. Who's supporting them? That's when you would go to a third-party supplier like us. So what we do is we have a team of AppSec experts that they can then support your security champions program for smaller, medium-sized companies that don't have an internal application security team. But that federated model works really well. And then again, going back to what I mentioned earlier, enabling the dev team. So, not relying on them saying, hey, I'm going to go to someone to do my design review, teaching them the basics, right? Like with threat modeling, some really basic stuff is, take your architecture diagram, look at where the data comes into your system, and then everywhere the data traverses, and follow the data. I always use the Star Trek analogy in my presentations. I put a picture of data, and that really makes people remember. They're like, hey, here's data. Follow data wherever data is going, right? From this interface to this microservice to this other interface, and look at places where an attacker could have an opportunity to intercept that data. And that's where you focus on your controls on, right? Now, that works really well at a high level for architectural threat modeling. But what also developers need to do is to take each of the functions they're building and apply a use case threat modeling to it. We're saying, okay, well, I'm writing a user story. As a user, I'm building this page. Maybe it's for a banking application that can view the transactions. So as a user, I should be able to view my own transactions. So it's really simple as putting a comma and a but, saying, but I should not be able to view other people's transactions, right? So those are really easy tricks that you can teach developers where they can start doing those things on their own, and also looking at it from a sort of a secure development lifecycle perspective. Whether teams are doing waterfall or agile or DevOps, there's always a point in time where some design is done and then some coding is done. So in waterfall, you take months to do do requirements, and then you take months to do requirements. Then you do months to code it. In Agile or DevOps, you're still doing those, but you're doing them within that sprint. So the security activities don't go away. When you're doing design, you should be doing a security design review. When you're writing that user story, you should threat model that user story. And when you code it, you should do code analysis, right? So you can still do all of those within your Agile or DevOps sprint, but you're doing smaller version of them. Instead of doing a design review on the entire architecture within that sprint, you're looking at the backlog of user stories that you had, and you're performing a quick design review on each of those user stories and threat modeling them. That becomes a lot simpler. It becomes a lot sort of effort intensive, if you will. And, developers get in the habit of doing that as part of their, sprint grooming and planning and design activities.
Yeah, no, totally. I mean, yeah, no, we felt that pain. I think the company had so many different application teams and application teams and application teams and product teams and feature teams and, infrastructure applications and, company-wide platform services.
Totally.
Who knows what? Yeah, no, I mean, and we did, I think eventually, I mean, you were spot on, have to get to a point where there was a security champion approach and having to get those by brand and by line of business. Definitely a process. And from the startup perspective, yeah, no, it's kind of cool that like forward security can basically be that central support function where it's like, hey, we have expertise, we can mentor your team, we can provide you that kind of back and forth, because a lot of startups are, to me, and just my opinion, a lot of startups early on will look and feel a lot like an early, say, feature or product team at a big enterprise. They have a lot of, they're all products, all the engineering is devoted to product, getting something out the door, building something, getting users, getting customers. And so an early stage startup just looks like pure product, no real, there's nothing really anything else, because it is. I mean, and that's what you'll hear, right? Because what is the focus? People expect like every startup founder to say, we're invested in building the product, we're getting, users on there, we're getting design partners and customers. But then it was like, there's no one to do anything else.
Totally.
And not in a way that scales, right? Because then hiring a dedicated security person, being one of those people, I know it's an important investment. Obviously, I'm biased, but it's not free.
It's very, yeah, exactly. And it's hard to find as well, right?
Hard to find. Yes.
One of the biggest mistakes that I see small, medium companies make is to go and hire application security people. Why do I mean, they should have a CISO, they should have security folks. But when it comes to application security, if you're a small company, let's say you have 2 development teams, you go hire an AppSec person, they're not going to have enough to do. So, in fact, when HSBC was going down this journey of like going to agile, management asked me, hey, can we assign an AppSec person to every team? I was like, well, number one, we don't have enough of them. And then number two, every team doesn't need one. So they insisted on doing that. So we added a full-time AppSec person to each of our flagship applications because we just didn't have enough for the rest of them. And then my consultants were coming and complaining. They're like, hey, Farshad, you assigned us to this team, but they just don't have enough stuff for us to do. They don't need a full-time AppSec person. Why did you assign us, right? So we experimented with how much of an application security time does a typical team need, and it's around 10 to 20%. So the average team doesn't need a full-time person. They need someone to come and help them about 10% of the time. Maybe instead of attending the daily stand-ups, they attend one stand-up a week. We call it a weekly stand-up. The essence of stand-ups are still important to be able to touch base to see what the priorities are, what the blockers are, move things along. But you don't need to do that every day for a given team. There's just not enough security. They're building business functions into the application. They're not going to talk about security every day. And so that's what we did is we fine-tuned it and we said, well, let's assign only 10 or 20% of these folks to these teams. Now, I see companies out there going and trying to hire someone. They go hire a full-time AppSec person. Well, several things happen. Number one, they have challenge finding them. Hiring an AppSec person takes about 10 to 12 months to find the right person. There's not enough of them. They're hard to get. They're expensive. So you go and, maybe you're lucky and you find someone. Then you hire them. That person is guaranteed to leave within 1 or 2 years. And I've seen this happen to colleagues and all that. Why do they leave? Because they get there and there's no one to bounce ideas off of. They're the only AppSec person. They want to propose a solution. Who are they going to bounce this off of? No one. No one else in there is there to support them or to present ideas or to brainstorm or to do peer reviews. And then the second is that they have no career in that company. That company might have a career ladder for their engineers and for other people, but because they only have this one AppSec guy, they may not even have a proper job description or career ladder. So this person, after a while, has no one to learn from. There's no career path. They end up leaving. So this poor company just spent 10 to 12 months finding this person, training them. This person comes in and then they leave. And I see this happen all the time. So my recommendation is, unless you're a large enterprise like Expedia or HSBC, where you can have, and you need to have an AppSec team, an AppSec function, and you can federate AppSec, you shouldn't go try to hire AppSec people. What you should do is try to do DevSecOps in the manner that I mentioned earlier as a cultural transformation. Really go and take your team and enable them in such a way that they can build secure software through automation, through process, through standards. OWASP has a great standard for application security called the Application Security Verification Standard. Any company can adopt that as, when they're wondering what controls to build into their application. They have lots of really good resources that teams can leverage and bake really good security into their products. And of course, automation is really important, right? I mean, there's a famous saying that tooling or vendor boxes don't solve all your problems in security, right? Like you can go buy all the boxes and tools you want, but you still need the people in the process. But there is a lot that the vendor boxes or the tools can do. So we shouldn't just throw them out the window saying, hey, tools on their own can't work. You need some people process. Tools do a lot. And in fact, in software security, you could embed static analyzers in your pipeline so that when your developers are checking code into the master branch, if you will, that's at least some level of security is running on the source code. Now, the problem with that is that traditional tools give a lot of false positives. Every team that I've worked with, including those at HSBC, the main complaint from the developers is, hey, Farshad, we went and put these tools and they gave us a lot of false positive and we just turned them off, right? We call that in the industry false positive fatigue. So to avoid false positive fatigue, what you got to do is you got to look at get tools that don't produce many false positives for your tech stack, right? So benchmark the tool against 2 or 3 other tools before you buy them. Don't just go and buy the first tool that came your way. Go and talk to vendors. Take a source code repository that represents your repo, and then run 2 or 3 different vendors' tools on that repo to benchmark which one does a better job. So get a tool that gives you low false positives to begin with, and then second, try to correlate the results across different scanners, because you're going to have your SaaS tool for static application security code testing. You're going to have your software composition tool that looks at the libraries that you're using. Shortly after, you'll be probably required to install dynamic testing tools as well. There are also infrastructure as code scanners, container scanners. You end up installing 3 to 5, maybe even 7 in some cases, types of scanners. And if you're not looking at the results across the different scanners and correlating them, you're losing the opportunity to figure out what's real and what's a false positive. So there are lots of different platforms out there, including the one that we're building, the Eureka platform, where you can correlate and aggregate and orchestrate all the different scanners and reduce that noise. And then you don't have false positive fatigue, and your developers will be happy and they'll use those tools. So that's the number one thing about the tooling. Tooling can address a lot of the low-hanging fruit, given that you pick a good tool that has low false positives and you're doing aggregation correlation. And then beyond tooling, really training and enabling your developers, as I mentioned earlier, to embed security as part of the DNA of that DevOps or Agile team. So as they're doing things, software is just coming out without low-hanging fruit. I remember the first year that I spent at HSBC doing AppSec. At the end of that year, I made a spreadsheet and I combined all the results from the different testing that I'd done for different teams. And then I noticed that it was the same 13 issues were happening in almost every one of the applications that I assessed. And then I was like, oh, wait a minute, this is why OWASP Top 10 exists, because teams tend to make the same mistakes over and over. And it's often the low-hanging fruit, things like SQL injection, cross-site scripting, and all that, which can easily go away with a little bit of training and enablement.
So I was thinking, Farshad, it'd be great after hearing about all the, like the top things that people should be doing. I think it's helpful that OWASP and NIST have that guidance that aligns around like how people can take real practical steps towards software security with the manual reviews, design reviews, and threat modeling, source code analyzers and whatnot. It'd be great to hear from you, with all your experience. Like, what are some stories you've heard from your peers, from your colleagues? Maybe things you've experienced firsthand. You don't have to name any names, but when it comes to maybe where you've seen people play, cyber roulette with risk and software security, and where maybe it went fine and maybe where it didn't go so great.
Absolutely. One of the ones that comes to mind is something was last year or the year before. A colleague of mine, none of the names to be mentioned or anything like that, but was doing some security work for a fairly large corporation in British Columbia up here in Canada. Very, very well-known organization. Most people in BC know what that is. And so she, knowing me, came to me and said, hey, we got a pen test done by some company, but I'm suspicious that if they found anything valuable. So can you take a look at the pen test report and tell me, if this is right or not? So in that pen test, quote unquote, pen test report, there were 3 vulnerabilities, not threat scenarios, 3 vulnerabilities. I looked at all those 3 vulnerabilities that they found, and none of them could actually be used to perform an attack on this application. As I mentioned, they were just vulnerabilities on their own, but there were no other vulnerabilities that you can combine as an attacker to be able to exploit that system. And the vulnerabilities that were discovered were really rudimentary. They were basic stuff. It was like, hey, there's a header that's missing when a request comes back from your service, and things that were just like real basic. Even if there was a threat scenario, it'd be low risk. then I started, so basically looking at the report, I told her, I said, these issues that they've highlighted, they're actually non-issues. They're not really a threat scenario. You don't need to bother with them. But then I started looking at the application myself, just interacting with it. And I was like, wow, it seems like there's lots of issues that are there that are not even in this pen test report. So what had happened is pretty much what I said earlier. The pen testing company didn't have people that understand software. The people that have probably tested it had never built software. And number two, they probably just scanned it and found some vulnerabilities. They didn't do any threat modeling. They didn't try to figure out, how you can combine these issues to attack the system. And they simply just presented that to the client. And of course, the client was smart. They came to me, and then I told them, look, you have bigger problems. You're getting a false sense of security. Yes, sure. The three issues that they've reported, they're non-issues, but that doesn't mean that your client should be happy. Hey, we have no issues. This is a clear bill of health, and we're good to go. This is actually an indication of, bigger problems that you don't even know about. Going back to what I mentioned with that false sense of security. So they're going to give you that report. You're going to think everything is okay. But in reality, they just even didn't test this property to really tell you what the actual problems are. So that's one thing I recall. Another client, fairly well-known financial institution in Canada, same thing. They'd gone and done a pen test with a fairly large brand, not to be named, but a brand that most of us are familiar with. They'd gone their pen testing done with them. 3 weeks they paid for, and they came back with an empty report. So the client was suspicious. So they came to us and said, hey, you guys know what's up. Can you take a look at this, or maybe come and test this again? So we went and did it according to our practices. We looked at design, threat modeling, code review, all that kind of stuff. We found over 25 issues, many of them high and medium risk. Whereas that other vendor, large brand, one of the big four that you wouldn't lose your job if you used them. But when the report came back, empty report, 3 weeks they charged for. And then we went and applied our testing methodology and found all the real problems. So those are a couple of examples stories that I can think of based on my own experience, but there's probably dozens more that I don't remember right now. One other thing I'd like to add as well is the value of threat modeling. We all remember the Capital One breach, right? So in the case of the Capital One breach, at a high level, what happened is that the attacker took advantage of a library or a package that was not updated. So they were using this reverse proxy firewall that was essentially just, I think it was just an Nginx with a mod security plugin. And that plugin hadn't been updated. So the attacker took advantage of that vulnerability, took over the machine where that software was running. Okay, so big deal, right? Now, from there is where it gets interesting. The next step in the attack was another vulnerability, that vulnerability being that the AWS environment for Capital One had a lot of loose permissions, right? And I've seen developers do this. I've done this myself. In the beginning when you're building things, you don't want to restrict the permissions too much because it produces a lot of blockers for your development. So usually relax all the permissions and the policies. You give every resource wildcard access to everybody as you're building it out. But what you're supposed to do is you're supposed to go and tighten those permissions after. So these guys hadn't done it. All their S3 buckets had wildcard permissions giving everybody access. So when the attacker used that application security vulnerability, took over that machine, they were able to use that machine's identity and access those S3 buckets because all those buckets were available to anyone, with any identity within that environment. So this is a case where two different vulnerabilities were combined to perform the attack scenario, the actual attack, right? One was take advantage of the library that was not updated. The second one was take advantage of the weakly configured AWS permissions. If only you combine those two, you have a threat scenario that can be exploited. On their own, they may not be a vulnerability. So this highlights the importance of doing your assessment, taking all the vulnerabilities from the application and the infrastructure and threat modeling it, seeing, hey, I've got all these different holes in my system. Which holes can be combined for an attacker to come through and gain access to my digital assets? And you really need to consider the holes at all the different layers. You can't just do your assessment on the application in silo and then do it on the cloud in silo and not do any threat modeling across them or at all. If you're not doing that, you're losing the opportunity to identify these really basic attacks like the one in the case of Capital One that could happen to you. So yeah, there it is.
I remember that one. That was a big one. I definitely remember everyone saying, hey, what are we doing about this? After it came out, that was like, hey, just checking. How big of a problem is this? Yeah, no, it's. There's so many places for it to come up.
Many places.
Yeah, so many places.
And another example is the Marriott and Starwood breach, right? So that one, what happened there is that the attackers were doing reconnaissance for, I think, almost 2 years. They were trying to find holes in their systems. And then after 2 years, this was what the forensics report came back and said, is that after 2 years, they finally figured out where the holes are and they executed their attack, right? This really highlights the value and importance of logging and monitoring. I'd say, again, following the 80-20 rule, 80% of software teams that I talk to don't understand it, have either not implemented it at all, or if they have implemented it, all they're doing is they're just saving logs to a file. I remember asking many teams this, okay, well, what are you doing about logging and monitoring? Well, we log all the actions into a file. What happens to that file? We don't know, right? Like, it's not going to a SIM. They don't care because it's someone else's problem, right? So developers either are not logging at all, or if they're emitting logs, they're just going locally and nothing is happening to it. So let's go back to the case of Marriott Starwood. The attackers had 2 years because logging and monitoring were not properly set up. If you set up logging and monitoring properly, when the attacker is trying to explore your application and learn about its vulnerabilities, what they'll do is they'll be testing things out, right? They'll call an endpoint with a payload that isn't a valid payload and see if it fails or not. So or they'll test your access control. So for that reason, it's really important that whenever your access control fails, you need to emit an event, a log event, saying, hey, someone did something that made access control fail. Why is that? Because a regular user logs in with their user credentials. They're interacting with the functions that they're supposed to. If someone is interacting with a function they're not supposed to, that's an indication that someone is trying to learn about your application and maybe attack it later. So if you were logging those failed authorization attempts or access control attempts, you would know that, right? Same, you should also be logging your input validation failures. Why would input validation fail? That's because someone is putting a character that could potentially be malicious and it failed your input validation, right? So there are a number of things. In fact, the 4 key things that OWASP recommends that you log and monitor, one of them being failure and success of authentication. The other one is failure of access control, failure of input validation, and failure of deserialization. If you were to start anywhere, implement those 4, and then not just log that stuff, emit them somewhere central where you're combining that and correlating it with other events within your infrastructure and corporate environment, endpoints and all that, to really get that full picture, because you might get a signal coming from the infrastructure that someone failed and like something failed or something fishy is happening. And if you correlate that with the event stuff that you're getting from your application, now you can see, oh, wait a minute, this guy was trying to get into my infrastructure, failed, and then went up here, tried to come through the application. This person might be trouble. My application is probably under attack, right? So really important to do logging and monitoring, but it's unfortunate that a lot of companies that are building software don't understand it or not doing it at all, or if they're doing it is very insufficient, if you will.
Yeah, no, I bet. I mean, I've heard that story before. If they are logging at best, and then like what happens to it. And so sometimes I think the security team has a hard time. They're used to getting network logs from edge network devices, from internal network devices, switches and routers, and firewalls and web servers. But a lot of the software logs are, they're so specific to the applications that they're from, especially within a software company. That's not some kind of standard vendor log. They're going to need a lot of help, I think, to understand like what those logs mean. From the security side, and then it's kind of like this circle where the security team will be like, hey, can you give us the important logs? And the software team's like, well, what are the logs that you need? And they're like, we need the important logs, and then it just goes in a circle.
Totally, 100%. And another thing I remembered that's worth mentioning is going back to how you test your application, when we were talking about earlier, a lot of companies will, not only will say, okay, I don't really understand it. Someone told me to go get a pen test. I'm going to get it done. They also don't understand the difference between black box and white box. And this is something I always try to educate our clients on. An attacker, they're doing black box, right? Because oftentimes they don't have access to your source code or your design review or anything like that. So what they do is they just try to have what they have try to use what they have access to, which is that IP address and that endpoint, and then just play with it to see what they can discover. That's black box. Now, what the attackers have on their side is time, right? Attackers, and in the case of Starwood and Marriott, they were doing reconnaissance for 2 years. So it can take a long time when you're taking a black box approach to really understand that system and then be able to attack it, right? If you're hiring someone to simulate that, which is most companies want to do, they go and hire a pen tester to simulate the attack, right? So when I tell them, hey, we shouldn't do this black box, they're like, well, the attackers do it in black box. Why shouldn't you? Why should I give you any design information or code or any architecture information? Why don't you do it like the attacker? My response is that the attacker has technically unlimited amount of time, and you're not paying for that. If you want a third party like us to come and do a black box pen test, then be prepared to pay us for a couple of years of testing as well for us to be able to find the same results, or open up the doors and make it a white box exercise. If you make it a white box exercise and you give us the source code and the design information, then within a really short amount of time, say 4 weeks, we can get the same results that an attacker could get in 2 years, right? But most companies aren't going to pay us for two years of black box testing. So that's usually an eye opener. Whenever I mention that, they're like, "Oh, you're right," because they're always insisting. They're like, "Well, why do you want our source code? Why do you want to do it differently? Attackers don't have access to the source code." So my rebuttal is always like, "Well, attackers have lots of time, and you don't have to pay for it. But in this case, you're paying for our time. Therefore, it's a lot better to go white box." And in fact, even OWASP in their ASVS, the Application Security Verification Standard, in the introduction, they mentioned that. They say you can test with OWASP ASVS level 1, you can test it against those requirements. And that's supposed to be black box, but then they'll add a sentence saying, keep in mind though, black box is not effective given a short period of time. And for the reasons that I mentioned earlier, because your code is custom, it's stuff that you wrote. So if you want that pen test to be effective, open up the doors, make it a white box assessment, give the source code to the tester, give the design information to the tester. Then with the limited time and money or budget that you have, then they can get a lot more better results than they would if you just gave them an IP address. But again, most vendors don't even understand that. So they'll take that IP address from the client, they'll do a black box, they'll take the money, they give them a report. And this is a huge problem in our industry at the moment.
Oh yeah, no, I do not. Just the whole black box thing, it's like, no, they should be given. It's like the attackers have so much information about your environment. I mean, what would be the point? You don't need to test the attackers who aren't going to be successful. You need to test the attackers who are going to be successful. Box tests are the ones that are going to be best because you want to see what are the most likely ways, what are going to be the least expected ways, and what are going to be the best ways to do it with all the information available. No, I feel very strongly about the white box versus black box. And I just don't know. The value of black box is just like, it's just exciting for the pen tester to be like, oh, look, I did it, black box, and whatever. Or the customer, like you said, is saying like, hey, the attacker they have more than that information, right? They're in your Confluence. They're studying your architecture diagrams. They're doing a better job keeping up with that than your app eng team. So that's their job.
Yep.
The attackers are highly motivated, highly rational, supremely efficient, waste no time.
Exactly.
Man, that is, those are some good ones. Oh yeah, I can feel my blood pressure go up thinking about those. It's just kind of like, having spent the overwhelming majority of my career on the kind of blue team defender side of things. It's just like every time I think about logs and monitoring logs and just looking at traffic logs for data going in and out of the environment, looking at the audit logs and the access logs, you're just like, please, I do not want to see the one thing that is going to tell me like, oh no, there it is. Yeah, that's too stressful.
Totally.
But no, I mean, it's super important, right? And I wish, have you seen any practical, there seems to be like a lot of good open source nowadays. There's open source projects available today I wish were available like 10 years ago. When it comes to helping, whether it's security teams or the software teams with getting better visibility of the application and the software, and around helping them do that, is it still just very kind of hands-on, everyone's got to do it from scratch, it's very bespoke, or is it expensive kind of vendor solutions out there? Or is it still just a lot of people trying to push syslog around and trying to figure out where to put it, or
in terms of logging and monitoring?
Yeah, logging and monitoring for software specifically, not infrastructure.
It hasn't really been standardized, and I think you hit it like you hit the nail on the head, right? Because they don't have a standard way of reporting these logs and things like that. So at best, teams, like OWASP does provide the recommendation, but not any format or anything like that. In ASVS, they have those controls that I mentioned. They say you should be logging your success and failure of authentication, your failure of access control, input validation, deserialization. What format you save it or anything, they don't mention it. So ultimately, most developers that I've seen, they just log it into a text file, which is fine. Log it into a text file, it could be syslog or something else. But then the question is, how do you ingest them and normalize them? And this becomes a bit of a mapping. So if you're using a traditional SIM, you have to just manually map those and figure out what maps to what and what happens. Or if you're really wealthy and you're using Splunk, which is quite expensive, Splunk tries to figure that out for you, which is really nice. Splunk can take any unstructured data and figure out all the relationships and everything else, but it comes at a hefty cost. So unless you're using Splunk, you can have to do some manual mapping and make sure your developers are following those ASVS recommendations. In fact, for anyone listening, I highly recommend you can just Google OWASP ASVS gold standard. And there's an article that I've put out, a blog post, very short. It helps you really understand what is ASVS, when do you use it, what are the use cases, what are the different levels. And it will take you less than 5 minutes to read it. And I highly encourage you to go and look it up and read it. And we could make it, Nick, available in the link in the this episode's copy for the audience. But that's a good starting place. Give that standard to your team. Say, hey, are we implementing these security requirements? There are about 279 security requirements in ASVS. Not every one of them needs to be implemented for your application. You can determine which ones are appropriate for your system. And OWASP makes it easy as well. They group them into categories levels 1 and 2 and 3. So if you read my blog post, I explain what the different categories are, levels are, and how you can leverage that. And so your team can then starting tomorrow, bake some of those security controls into your application, including the logging and monitoring ones. And then really the next thing you should do is, once you've identified your gaps and what you have and what you don't have, look at logging and monitoring. Try to implement that appropriately based on what OWASP's ASVS recommends.
Yeah, no, I think that'll be great. We'll make sure to include the link with this episode. No, we will be sure to do that. I mean, so on that note, I think we've definitely really appreciate going through. I think all these, some of it may be refresher for a lot of people. Some of it may be new if they're coming from different domains within security, or they're coming from the software side. But I think it's going to be super helpful for folks to kind of take a step back. There's a lot of things they might be able to do today. Some things they may be able to get help with if they don't have it today. And I think, there's a pretty robust and growing security community out there of practitioners who are helping out each other, whether you connect through different events like B-Sides, or I think there's the, is it the Blue Team Con, or what is it called? Blue Con? I don't know. There's a Defender Con. There's so many conferences. Right. But I think they're great places, right? To meet folks. Yeah. Exchange ideas and practices.
Exactly. And if you live in the Pacific Northwest, we organize the OWASP Application Security Pacific Northwest Conference. It happens every year in June. We just had this year's in Portland. Next year in June, it's going to be in Vancouver. But beyond that, there's monthly meetups. Whatever city that you live in, OWASP has chapters in most major cities or areas. And so go to their free meetups. There's really good discussions, a lot of good presenters that talk about different areas of application security. If you look up OWASP threat modeling, they have a really good guide on how to get started on threat modeling. Lots of freely useful tools. They have this security knowledge framework, which is a project that helps developers, learn application security. They have different modules that demonstrate different application security problems with code examples and guides. There's lots of free open source scanners as well that you can incorporate into your CI/CD pipeline. If you're using Java, for example, Find SecBugs is a really good SaaS tool. SemGrep, there's a community edition that you can use, and they have commercial editions as well. SemGrep, in my opinion, is one of the best SaaS tools out there. There's SonarQube also has a free version, but be careful with the SonarQube free version because it doesn't really do any security checking. You have to go to the paid developer version for the security checks to work. Mm-hmm. But lots and lots of open source software. But then remember, if you're using open source, it's free, but it may have a lot of false positives. So it could be a good starting point for your organization if you don't want to commit to a paid system. And of course, keep in mind that you could use correlation aggregation orchestration platforms like our Eureka platform to bring more value to those open source products. So you could combine all your scanners, run them together, and then correlate the results to really figure out what is an issue and what's not. So all those things can help a team get started, and then start with incorporating SaaS. It's software application security testing. I can't remember what it stands for exactly.
Analysis,
static
testing.
application. Yeah, static application security testing. That's right. And then SCA, which is software composition analysis. Those are the easiest and best places and most effective places to start. Once you've got those in your pipeline and you're doing aggregation and correlation, hopefully, then you would start to add other tools like DAST. So when I work with clients, we start with SAST and SCA, then we go to DAST, and then we look at putting other things like infrastructure as code scanning, or maybe even IAST. IAST is really good, interactive application security testing. Contrast is one of the companies that has really championed this domain. Synopsys and others have tools in that space as well, but it allows QA teams to instrument the tools. So by embedding the agent in your QA within your service while you're doing QA, you get visibility from the inside, and that truly reduces the false positives as well. So highly recommend looking into those types of tools.
Yeah, no, I think those are great. That's a great list of resources. Really appreciate you sharing that. Well,
my pleasure.
Farshad, it was always great, always a pleasure. I think, I've learned the most throughout my career in security from folks and peers, and friends and colleagues like yourself, and hope other people are able to go out into your community wherever you are, or, fortunately we have the internet, and connect with security folks who are in your domain, in your industry, in your space. And I think a lot of folks are happy to help. And, sometimes those are the fastest and easiest ways to learn. Thanks for taking the time to share that with us.
Thanks for having
our listeners. And, we'll hope to talk to you soon, Farshad. Take care.
Take care. Thank you for having me.